Bismillah ar-Rahman ar-Rahim. Let's look at this shear and moment. This is shear. This is only shear. So here we have a reaction. Ooh. AY is 2.5. Ooh. Bx, there's no forces in the x, there's one force in the y. So he gave you by and he gave you ax, 2.5, 3.5, and we want to draw the shear diagram. So initially I'm gonna extend the line I'm gonna have the shear. I'm gonna call it V shear, and I'm gonna call it, of course, kilonewton. This is the description of the shear. And now, initially, I will start from 0, because initially we will start from 0, and then you can see here that there is a uniform distributed load for 3 meters. So it will go down. And since the uniform distributed load is at the load, it's uniform, the shear would be linear. And of course, linear down because the force is down. So this is 2 times 3. It is 6 kilonewton. So it is minus 6, so it's gonna go down. So 0 minus 6 until this point. So this is of course, this is linear. So this is minus 6. Now, at this point, at the end of the uniform distributed load, there is also a ruler going up, 2.5. So minus 6 plus 2.5, you go up at this exact point, minus 3.5. Later on, you can see that there is no load. Don't worry about the moment. Here we are doing the shear diagram. We are not doing the moment diagram. So we don't care about this moment. And since there is no load throughout, the shear is constant until this point. And at this point, it is minus 3.5, and then gonna go up 3.5. Okay, so we have a good check. So this is still minus 3.5. Gonna go back to 0. So this is the shear diagram of this beam. Let me just take all of these things. Okay, so this is the shear diagram. But he also wants determine the shear as a function of x for each segment. Well, here we could notice if you take a cut just before this ruler, what is the equation of the shear as a function of x? As a function of x. So let's take just before the ruler. And let's do the cut at a distance x before the ruler. So we did a cut here at a distance x. So the load is still constant. It is still uniform. So it is 6 kilonewton per meter. If you multiply the load, the uniform load, times x, that would give you a point load 2 times x, because the distance is x, that the cut that I did for. This is 2 kilonewton times x. Now, let's find the shear. Let's assume that the shear is up like that. Okay? So the shear up, let's do summation of forces at y. For the shear, you do only y. equal to 0. Shear minus 2x equal to 0. So shear is equal to x. Well, the only problem here that according to the science convention, this shear, if it's going up by looking at this shear from the right, this shear is negative. So we could have that the shear here, it is minus 2x. This is the equation of this segment. And you don't have to worry about finding a cut after the ruler, because you can see the shear here. The shear here is equal to minus 3.5 kilonewton, exactly constant. And the shear here is minus 3.5 kilonewton. You don't need to do a cut. But if you have all this time to do a cut and you will find out it is minus 3.5 kilonewton. I think we are done from this problem. This is a very easy one. I know any student might ask, really, let's do a cut and see. Okay, let's do a cut. Let's do a cut at any point, at this point. Okay, just for curiosity, let's just do a cut. So if you do a cut at this point, whether it's before the moment or after the moment, who cares? We have this uniform distributed load, 2 kilonewton per meter, and this is 3 meter. And also you have the force, 2.5 kilonewton, and we did the cut here. Again, it doesn't matter before this moment or after that moment. It doesn't matter. So I'm going to have the shear up, and that's it. We need to find the shear. That's it. Nothing else. We don't need to find normal force or moment. This is the shear diagram. So let me just go again. So summation of forces at y equal to 0. This is positive shear plus 2.5 minus 2 times 3, 6. 2 times 3 is 6. So shear 2.5 minus 6, and that's going to give you 3.5. Again, this shear, by looking at the beam from the right, this shear is positive. Okay, because it will do counterclockwise moment with the other shear from the other side. So that's true, minus 3.5 kilonewton throughout until this point, pen B. So I guess we are finished from this problem, and let's do the next one.